Alright, so let's go through checkpoint 2. So we have these three charged particles. So two is negative charge, one is positive charge. So the 2 microcoulomb charge exert a force of 12 Newton on the negative 6 microcoulomb charge. So what is the net force experienced by the negative 2 coulomb charge? Okay, so first thing, I need to calculate what is the distance first between the positive 2 and negative 6 microcoulomb. So of course they give us something, right? They give us the force is 12 Newton. Then of course you must know that K, right? The K is 8.99 times 10 to the power of 9. This one is something that you must memorize lah. So for the big Q, you can put 6 times 10 negative 6. So just take into account the magnitude will do. Don't need to put negative or positive. So this is 2 times 10 power negative 6. So what you need to do now is to calculate what is the error between them. So if you do the calculation, right, the error should be roughly 0.09481561 meter. Okay, so now I want to focus my attention on this part. Okay, so imagine that we have this negative 2 microcoulomb. So if you look at the negative 2 microcoulomb, right, and this negative 6 microcoulomb, so the separation is the same, right? So it's about 0.0948, so and so forth. So they will actually repel one another, right? So means that this negative 2 microcoulomb, right, will experience a repulsive force from the negative 6 microcoulomb. So this force, actually you don't need to calculate because it's given already, 12 Newton. So this is 12 Newton. Okay, so what I need to do is to calculate what is the attractive force acting on the negative 2 microcoulomb by this thing. Okay, use this green color. So it will experience a attractive force, right, towards the left hand side. So let's draw here. So to calculate this force, you can use, for example, right, F equal to KQ Q over R square. So we know that K is 8.99 times 10 to the power of 9. So the both Q is 2 microcoulomb, means that you can just put 2 micro, right? So times 10 negative 6. The whole thing, right, to the power of 2. Then what about the R square? The R square, because they say that the distance is the same, right? So means that, okay, from here to here is 0.0948. From here to here is also 0.0948. So you just need to do the 2 times 0.0948 bracket the whole thing square. So you will notice that your attractive force, which is rather weak, is about 1 Newton. So this is 1 Newton. Okay, the next part will be, they say what is the net force, meaning what is the resultant force experienced by the negative 2 coulomb charge. So you just use 12 minus away 1. So this will actually give you 11 Newton. So that is how we do checkpoint 2.